Hi students, today we are dealing with miscellaneous series. We observed in previous videos AP, ZP and HP. Now we are observing miscellaneous series. Those are combination of arithmetic and geometric. Okay. Now you take our arithmetico-geometric sequence. That is, it is satisfying the sequence which satisfies both AP and GP. That can be called as arithmetico-geometric sequence. Okay. Now nth term of AGP. So this can be called as in simple terms AGP, arithmetico-geometric progression. Okay. Now this is in the form of like this. Say if A1, A2, let me take, we will find the nth term. So before that, let me write, okay. Yeah. Say A1, A2, A3, AN. A1, A2, A3, so on, AN is an AP. Okay. B1, B2, B3, so on, BN, so on is an GP. Okay. And AN, so on. We take so on. Okay. Is an AP and GP. Then A1, B1. Then the sequence, what do you say? A1, B1, comma A2, B2, comma A3, B3. A3, B3, so on, AN, BN, is this can be called as our arithmetico is called AGP. Understood? So now we are finding the general form of this arithmetic geometric sequence, arithmetico geometric sequence. Yeah. For that, let us take our series, how it will be. So first one is A. Second term should be A plus D times R, right? Because it has to satisfy both EP and GP. So first one in A and A plus D. But in GP, A and AR. So instead of AR here, A plus DR, okay? A plus 2D R square, A plus 3D into R cube, okay? So on. Like this you will get, okay? So this is the this is the AGP, arithmetic progress arithmetico-geometric sequence. Okay. Now, if you write the series, what it becomes? So, arithmetico-geometric sequence, this is arithmetico-geometric sequence. Okay. If you want to write series, what you have to do? Just you put plus sign, right? By adding all the things, you are getting the series always, right? That is the difference between sequence and series. Understood? A plus 2D into R square plus A plus 3D into R cube, okay, plus so on. What is this? This is arithmetico-geometric series. Understood? Series. Now, arithmetico-geometric series, how do you find the sum of this? Let us find the sum to n terms. Come on. So what is sum to n terms of arithmetico-geometric sequence? Same, arithmetico-geometric sequence is, what is our sequence? A plus D times R. So what we are finding? Sum to n terms of AGP. Okay. A plus D into R, A plus 2D into R square, A plus 3D into R cube plus so on. Right. So for the sum is given by Sn is equal to A by 1 minus R plus dr into 1 minus R to the power of n minus 1 by 1 minus r whole square minus a plus n minus 1 times d by 1 minus r whole power r power n. So for this total thing, whole power r power n. So this can be possible only when r should be, the value of r should not be equal to 1. Okay, r should not be equal to 1. Similarly, this can also, when r is equal to 1, what will be the sum? So the sum will be n by 2 into 2a plus n minus 1 into d, normal sum. Okay, where r is equal to 1. If r is equal to 1, then this is the sum. If r is not equal to 1, what is the sum? A by 1 minus r plus dr into 1 minus r to the power of n minus by what? 1 minus r square, r minus r whole square minus a plus n minus 1 into d by 1 minus r whole to the power of r to the power of n. Sorry, not whole to the power of what I have written. Into r to the power of n. Okay. This is into, not r to the power of n. If you write r to the power of n, what will be the answer? Yes. So not r to the power of n, sorry. It is into r to the power of n, where r should not be or never be 1. Okay. Got it? Now, in the same way, we can find, or otherwise can we do one example? Okay. First, let me do one example, then we go with other topic. So, example, let us take 1 plus 2 into 2 plus 3 into 2 square plus 4 into 2 cube, 5 into 2 power 4 plus on up to 20 terms. So, how many terms? 20 terms. So, I want to calculate Sn. What is the formula for Sn? Sn is equal to A by 1 minus R plus dr into 1 minus r to the power of n minus 1 by 1 minus r whole square, yes, minus a plus n minus 1 into d by 1 minus r, okay, into r to the power of n. Yes. So, how do we substitute? Come on. A. A is 1 by 1 minus 2. Yes. 1 minus 2 because R is 2. Hmm? Plus 1 into 2. D is 1 into R is 2. And 1 minus 2 to the power of n is 20. Right? 2 to the power of 20 minus 1. D minus 1 divided by 1 minus 2 whole square. Okay. Minus 1 plus 20 minus 1 into 1 divided by 1 minus 2 into, sorry, this one would be here, close the bracket, okay. This much into 2 to the power of 20, right, into r to the power of n, this one, okay. Now what do we get? 1 by 1 minus 2, 1 by minus 1 into, so 2 into 2 to the power of, how much? 2 to the power of 19, no? 2 to the power 2, I took common here. 2 to the power of 20, sorry, 19 minus 1 by 1. Okay. And here, what do you take common? I think we cannot take any common. We can write directly. 1 plus 20 minus 1 by minus 1 into 2 to the power of 20. Right? So, what do you write now? Put this 1 minus 2 to the power of 20 plus 2 plus 2 plus 2 to the power of minus 20. Okay. 1 minus 2 to the power of 20 plus 2. Yeah. Plus 2 plus this is minus 1 minus minus plus 2 plus 2 to the power of 20. Next, sorry, how much we got? 1 minus 2 to the power of 20 plus 2. 20 also there, no? Here. 20 into 2 to the power of 20. 20. 20 times 2 to the power of 20. Okay. What do we get now? So 22 to the power of 20 minus 2 to the power of 20 plus 1. How much will get? So this is 19 2 to the power of 20 plus 1. Yes. So this will be the final answer. Got it? Can I erase this? Come on. Let us erase this. Now, sum of infinite sequence in the same way. Sum of infinite sequence. What is sum of infinite sequence? Say, I am taking mod r. If mod r is less than 1, then what happens? Then for r to the power of n, you observe r to the power of n, and or otherwise you take r to the power of n minus 1 tends to 0, right? As n tends to infinite, right? So it can also be written as, how do we write? N or n in r to the power of n tends to 0, n into r to the power of n tends to 0 as n tends to infinity. Okay. So we obtain, how do we get? S infinite is equal to, or first we will write Sn. Okay. Sn we will write. Sn is equal to, what do you write? A by 1 minus r plus dr by 1 minus r square, okay, as n tends to infinity. Got it? Now, in other way, how do we write this same? So can I write this as S infinite is equal to A by 1 minus r plus dr by 1 minus r whole square. Okay? Understood? Yes. Next, we observe the next part, method of finding sum. How to find the sum? Yes. Say I am giving one example now. We take one example. 1 plus 2 into 1 by 2 plus 3 into 1 by 2 whole square plus 4 into 1 by 2 whole cube plus 5 into 1 by 2 whole to the power of 4 plus so on up to infinite. Okay? Up to infinite. Now here A is equal to 1. R is equal to half. So that means, what do you get? We get R should be, mod R should be less than or equal to 1. And common difference is 1, right? Common difference is also 1. So can you write S infinite? S infinite is equal to A by 1 minus R plus dr by 1 minus R whole square. Okay. Now, so I am substituting the values 1 by 1 minus half into dr. Dr is 1 into half, right? By 1 minus half whole square. What do you get now? 1 by 1 minus half plus 1 by 1 minus half plus, no? Middle is plus, okay? What do we get? So if you calculate this, you are getting 2, no? Okay. And 2 plus 1 by 1 by 1, 1 by 2. So how much? 2 plus 2 is equal to 4. Okay. In this way, you can easily do the things using formula. Okay. So just remember S infinite is equal to AGP formula A by 1 minus R plus dr by 1 minus R square. If you remember that, you can easily do either sum to n terms or sum to infinite terms. If R is less than, mod R is less than or equal to 1, then you will get this. If is equal to 1, A by 1 minus R. Got it? Yes. Let us go to the next part. What is the, you got an idea on what is a sequence that is AGP. Okay. Now method of finding sum. How to find different properties, how we are finding different way. So before going to that, let us observe some important results. What are important results? Come on, let us observe. So A and G be the A is AM, G be the GM between A and B. Okay. Then A and B are, how are A and B? A and B are A plus R minus root of A plus G into A minus G. A plus G into A minus G. Got it? In this way, you can calculate between two distinct numbers A and B. So this is between GM between A and B. So we are finding the GM between two distinct numbers. Two distinct numbers A and B. What is its GM? If A power n plus 1, A power n plus 1 plus B power n plus 1 by A power n plus B power n. Okay. What is this? Is, so we have different conditions. It should be an AM. When, if it is an AM, then n is equal to 0. Next, second condition, HM, if n is equal to minus 1. N is equal to minus 1. Next, the equation, if you write the equation whose roots are A and B. Whose roots are A and B, you can easily write down x square minus 2ax 2a 2ax 2ax plus x square, sorry, g square is equal to 0. X square plus 2ax plus j square is equal to 0. Like this, we can easily calculate by using these results. Okay. Like this, we will observe some more results in this. Come on. That is, if you take the equation whose roots are A, B, C. If the roots are A comma B comma C, then A comma B comma C is x cube minus 3ax square plus 3g cube by h into x plus g cube is equal to 0. If the roots are given, you can write the equation like this. Okay. AGH, AM, GM, HM. AGH for AGH are sequences or series, whereas AM, GM, HM are simply numbers. If ABC or GP, you take next one A comma B comma C are in AP or in AP or in AP, okay, as well as GP or otherwise AP, GP or AP, GP and HP or HP you take otherwise or HP, okay, AP, GP or HP. So according to that, what do you say? A minus B by B minus C is equal to A by A, right? Or we can write A by A by A by B. We can write A by A or A by B or A by C. A by C. Okay. Next, a series which is an AP, GP and HP. Can you guess which series is both? Which series? What kind of series is AP, GP and HP? Three sequences are satisfying by single series or single G sequence. What is the name of? Can you give an example for that? Not an example, it is on single one. What is that? Can you guess? Yeah, very good. It is 1, 1, 1. Okay, this can be satisfied. This satisfies AP, GP, and HP also. Okay, next. No term of an HP is 0. That is very important. No term of HP is not 0 or no term of HP is 0. So 0 we are not getting any kind of term in the case of HP. If ABC are, next point, if A comma B comma C are pth, qth, pth, qth or terms of of GP, okay, then A power Q minus R into P power R minus P into C power P minus Q, which is equal to 1. Okay? This is very important to read. When it is possible, A, B, C are Pth, Qth and Rth terms. Okay? Next, A, B, C are in GP and A power X, A, B, C are in GP. Okay? These are in GP. Then what are they asking? If ABC are in GP, then A power X. So in the same way, in the power form only we will observe first A power X is equal to B. Sorry, A power X is equal to B power Y is equal to C power Z. Then what do you write? 1 by X, comma 1 by Y, comma 1 by Z. These are in AP. Got it? These should be in AP. If ABC are in GP, then what do you write? That is the next point. So ABC are in GP, then what do you get? So if ABC are in GP, yes, A comma B comma C, let me write that. If ABC are in GP, okay, then what do you get? B square plus C square by B square plus A square is equal to C by A. This is one rule. Okay, important rule. Got it? Yes. Next. If pth term, pth, qth, orth terms of GP is truth of terms of GP or in GP, then PQ or in AP. Okay, this is next. If H is the HM between A and B, now about harmonic mean. H is the HM between A and B, then H minus 2A, H minus 2A into H minus 2B, H minus 2B is equal to H square. Understood? And also, if A and B, H is the HM between A and B, other one also there. 1 by H minus A plus 1 by H minus B, 1 by H minus A by 1 by H minus B is equal to 2 by H, is equal to 2 by H. Right. 2 by H. Okay. Next. This can also be sometimes if you want to get this in terms of A and B. So you are getting 1 by A plus 1 by B. Okay. Next. H plus A by H minus A plus H minus H plus B by H minus B is equal to 2. Okay. H plus A by H minus A plus H minus B by H plus B by H minus B is equal to 2. Next, the last one, this is important one. So it says that if ABC are in GP, ABC or in GP, ABC or in GP, then A plus B, I am taking B plus C and C plus A. These are in HP. Okay, this is very important. Understood? Like this, we can observe the different important points regarding to this. What do you say? AGP, and under that, the important results. What are the important results in AP, GP, and HP combinedly? We completed. In next video, I am going to teach you how to find the sum of series. Say some special series are there. Okay, VN method. That is very good method, and if you learn the formula, you can easily do any kind of big question. Okay, that video. So in that video, we are going to cover VN method of finding sum of the series, like different types. Say 1 by 1 into 2 into 3 plus 1 by 2 into 2, 3 into 4, like that. One kind of series. Another one is 1 into 2 into 3 plus 1, 2, 3, 4, 1, 2, 2, 3, 4, 5. Like different types. Okay, by using that formula, by using the different formulae, we are going to calculate the special series. Those can be called as special series. We can find the formulae, direct formulae, we will write, and then we are going to do some examples related to that formulae. Okay, don't miss the video. Okay, okay then, bye, thank you.